Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to the third lesson on the frustum of pyramids and cones. In the last lesson, we learned how to calculate the surface area of a frustum. We also learned how to calculate its volume. Today, we are going to expand our knowledge of frustum even more. We are going to learn how to calculate the surface area and volume of the frustum of a cone. Are you ready, students? Let us begin. This is a familiar looking shape, is it not? It is the frustum of a cone. Please take a moment to make a list of objects that you have seen which have the same shape as the frustum of a cone. You may get started now, students.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. What objects were you able to list? You might have thought of a bucket or a water glass. You might have said a lampshade, a megaphone, or a flower pot. All of these are good examples of frustum. The bases of this frustum are composed of the base of the cone and the cross section parallel to the base. The lateral surface is the curved surface that makes up the frustum. The altitude is the perpendicular distance between the bases. The slant height of a frustum of a right circular cone is that part of the slant height of the cone which is included between the bases. Students, please get ready to follow along as we learn to calculate the surface area of a frustum. This frustum has a height of 8 centimeters. It is formed from a right circular cone that is 16 centimeters tall, and its base has a radius of 12 centimeters. We will designate the area of the base, the area of the cross section, and the area of the lateral surface as AB, AC, and AL respectively. The ratio of the cross-sectional area to the base area is equal to K over H squared. In this case, that ratio is equal to 8 over 16 squared, or 1 over 4. The base of the frustum is a circle, so it is equal to pi times r squared. For this frustum, the radius is 12 centimeters. Therefore, AB is equal to 144 pi centimeters squared. We are left with the equation AC over 144 pi equals 1 over 4. This is all the information we need to calculate that AC equals 144 pi centimeters squared times 1/4, or 36 pi centimeters squared. Since AC equals 36 pi centimeters squared, it is also equal to pi r prime squared. We can therefore remove pi from the equation. The square root of 36 centimeters squared is 6 centimeters. Therefore, the radius of the cross section is 6 centimeters. The slant height of a cone is found with this equation. Students, can you calculate the slant height of the cone? Do you think that you can use this equation to calculate the slant height of the frustum? In groups of 2, see if you can find a way to solve this problem.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Let us see if you were able to calculate the slant height of this frustum. We can find the slant height of a cone by calculating the square root of the sum of the squares of the height and the radius. For the larger cone, the slant height is 20 centimeters. For the smaller cone, the slant height is 10 centimeters. 20 centimeters minus 10 centimeters is 10 centimeters. Therefore, the slant height of the frustum is 10 centimeters. Were you able to find that answer, students? If you did, great job. The lateral surface area of a cone is equal to pi times slant height times radius. The larger cone's lateral surface is 240 pi centimeters squared. The smaller cone's lateral surface is 60 pi centimeters squared. Therefore, the lateral area of the frustum is equal to 180 pi centimeters squared. For the frustum of a right circular cone, the lateral surface area of the frustum is given by this equation. The altitude and slant height are expressed by h and L, and the circumferences are expressed by C and C prime. The lateral area is equal to 1/2 the slant height times the sum of the circumferences. This can also be expressed as 1/2 the slant height times the sum of 2 pi r and 2 pi r prime. It is also equal to slant height times pi times the sum of r and r prime. Please make a note of this, students. It is time for another activity. The frustum's volume is expressed by this equation. Using what we have learned about the frustum of this cone, can you calculate its volume? Please try to do that now.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. We can see that the volume of the frustum is given by the equation of 1/3 pi times the difference between the product of the larger cone's height and squared radius and product of the smaller cone's height and squared radius. In this case, the volume of the frustum is equal to 16 times 144 minus 8 times 36 multiplied by 1/3 pi. The difference is 2016. When we multiply this result by 1/3, we are left with 672. The volume of the frustum of this cone is 672 pi centimeters cubed. Did you manage to find that answer? Well done, everyone. That is all for today's lesson, students. We have learned how to calculate the surface area and volume of a frustum of a cone. Be sure to practice this process on your own. Until next time, thank you, teacher. Thank you, students.